आवाज आ रही है?
Yes, sir.
अच्छा, मैं फिर इधर से स्टार्ट करूं। I'm just going to keep practicing this one, ठीक है, for now. So let's say I've got अगले क्वेश्चन पे आ जाते हैं, ठीक है. So question number 6. अच्छा, let's say I've got किसका करें reaction? I've something that's unfamiliar. uh, करते हैं कि did I do SN? तो ये कर लेते हैं. तो देखते हैं कि now I don't know if this reaction will happen or not. Let's say SnCl2 and now I have no idea acidified H2O2. अच्छा, so I have no idea whether there's going to be a reaction or not. सबसे पहले I'm going to find out what my reactants are, ठीक है, who's involved. So I've obviously got SN2 plus. Remember मैंने कहा था कि ionic compounds को, I mean, you have to think of the ions as separate species. अच्छा, Cl ions है इसमें. acidified का मतलब है कि बस वो H2O2 के साथ ना there is H plus 1. अच्छा, ये सारे reactions है. अच्छा, now I'm going to try and write down all possible electrode reactions involving these substances, क्योंकि अभी तक मुझे कोई आइडिया नहीं है कि इनमें से कौन गेन करेगा, who's going to lose electrons. So what I'm going to do is I'm going to look for Sn2 plus है मेरे पास. Remember that. So I've got this equation. It gains electrons. It's minus 0.14. I'm just going to copy this, ठीक है. So I've got one Sn2 plus 2 electrons in equilibrium with Sn. क्या वैल्यू थी इसकी? It's यहाँ पे थी minus 0.14. अच्छा, फिर और कोई है Sn2 plus. Is there Sn2 plus somewhere else? ये एक और है Sn2 plus, ठीक है. अच्छा, रिमेम्बर राइट या लेफ्ट पे ना, इट डजंट रियली मैटर. बस वो राइट और लेफ्ट का मतलब होता है कि क्योंकि इट्स रिवर्सिबल, ठीक है. तो लेफ्ट पे होगा तो वो फिर ऑब्वियसली गेन कर रहा होगा. अगर वो राइट पे होगा तो इट माइट बी लूजिंग इलेक्ट्रॉन्स, ठीक है. सो आई हैव गॉट दिस अदर वन व्हिच इज 0.15. सो आई एम जस्ट गोइंग टू कॉपी दैट. तो ये क्या है? इट्स Sn4 plus 2 electrons. और ये कितना था? 0.15 वोल्ट्स, ठीक है. तो Sn2 plus Cl का तो वही था. Cl क्लोरीन है. दैट्स उसका एक ही रिएक्शन, वो पहले भी ऊपर लिखा हुआ था. So Cl2 plus 2 electrons in equilibrium with let's say 2Cl minus 1. This was 1.36 volts. अच्छा, acidified H2O2 ढूंढते हैं कि is there acidified H2O2. बस दुआ करो रिएक्शन हो, वरना टाइम ही जाया करेंगे हम. एक सेकेंड. where's कहीं नजर आया acidified? अच्छा, H2O है. नहीं, right now not on this page. One second, next page. Acidified H2O2. तो हाँ, ये एक है. एसिडिफाइड का मतलब है कि वो साथ मैंने एसिड डाला हुआ है, ठीक है. सो आई गॉट दिस वन. सो प्लस 2 इलेक्ट्रॉन्स 2H2O. नहीं उम्मीद है कि रिएक्शन हो जाए, ठीक है. सो so H2O2 plus 2H plus 1. Let me just copy it. अच्छा, और ये क्या? 2H2O 1.77. अच्छा, ये आ गया. अच्छा, and then there's another one which is I think just H2O2, I guess. There is one ये यहाँ पे. There's another H2O2. और तो कहीं नहीं H2O2. Yeah, I guess that's it. So there's another one which is O2 plus 2H plus 1. So you got H2O2 over here. That's 0.68. तो इसको भी पिक कर लेते हैं. O2 plus 2H plus 1. I think H2O2 बन रहा था. And this was 0.68 volts. अच्छा, मैं मार्क कर लेता हूँ. Why did I pick each one of these equations? क्योंकि this one was Sn2 plus, this one also had Sn2 plus. Cl minus 1 था, so I had Cl minus 1, I had H2O2, इनमें H2O2 था, इसमें acidified था, इसका खाली H2O2 था. ठीक है, so हो सकता है maybe just H2O2 might be reacting. ठीक है, maybe you don't need H plus 1, so not really sure. अच्छा, now next step, the highest potential out of, so I've got all possible electrode reactions which involve my reactants. Now the highest one is going to gain electrons. So इनमें से which one is the highest one? कौन gain करेगा?
Fourth one.
ठीक है, तो fourth हमारा जो है ना, fourth one, that's the highest. That's so this one is it's my highest potential, and it's going to go in the forward direction. और इसमें कोई मसला नहीं है क्योंकि who's gaining electron? If I select this as the highest one, then it's H2O2 and H plus 1 that are gaining electrons, which is perfectly fine because दोनों चीजें मेरे पास. I've got both of them. ठीक है, तो ऐसा, so I've got both of them. तो ठीक है, इसमें कोई मसला नहीं है. So I've easy, ये काम easy हो गया. I've figured out who's the highest potential, who's going to gain electrons. अच्छा, lowest में मसला हो सकता है. Lowest में who's the lowest who's going to lose electrons? So my, according to my possible reactions, it's minus 0.14. That's the lowest. That's the one that's going to lose electrons. Now, so it's going to lose electrons, right? It's got the greatest tendency to actually lose electrons. Lekin issue ये कि it's Sn that's losing electrons. So I don't have the. अच्छा, remember, focus on the reactants. Products कुछ भी हो सकते हैं. मतलब product पे कोई limitation. Anything could be produced. The reactant is the issue. You have to, I mean, the reactant should match with your reactant, so which is not happening over here. So I've rejected it. ठीक है. Okay, although it is the lowest, although it has the greatest tendency to actually lose electrons, lekin the thing that's losing electrons, I don't even have that thing. So it doesn't even apply to my reaction. ठीक है, ये clear है?
Yes.
Yes.
अब आ जाओ तो lowest ये है, मतलब बाकी सारों में तो फिर ये lowest रह गया. So that's the one that's going to lose electrons. So ठीक है, so there's nothing wrong with it क्योंकि it's Sn2 plus that's losing electrons. I got Sn2 plus in my reactants over here, so there's nothing wrong with this one. तो बस इन दो को ही कर लेते हैं हाईलाइट. हमने सिलेक्ट कर लिया कि क्या होगा. तो एक ये हो गया और एक हमारा ठीक है, ये दो हाईलाइट हो गया. And that's it. So I'll just or electrons gain and lost is also equal. Okay, so I don't need to 2 electrons lost, 2 electrons gain. So I don't need to multiply any equation by any number. I can just directly add them up. पहले वाले के reactants उठाओ. The reactant in the first one is Sn2 plus. Okay, so I got Sn2 plus. Second one, the reactant is H2O2 plus 2H plus 1, and the product is पहले वाले में it's Sn4 plus. And in the second one, it's 2H2O. वही है ना? ठीक है, so my reaction is complete. I have figured out what my reaction is going to be. ठीक है, तो वो इतना complicated कि I just came up with random reactants, just put them together, and I figured out so we have figured out with quite a certainty what the reaction is going to be. And next thing is you can calculate how fast the reaction will be. You can figure out the E naught cell, which is the reduction potential, which is 1.77, minus the oxidation potential, which is 0.15. मतलब दोनों का difference. ठीक है? So that also comes out to be like a big value. क्या value आ रही है?
1.62.
1.62 volts. ठीक है? So high potential. That means electrons would flow very quickly between the two. and you'll have a kind of a very feasible reaction, a spontaneous reaction. ठीक है? Clear है? Done? ये चीज clear है?
Yes, sir.
Yes, sir.
अच्छा, इसमें टाइम जाया ऐसा नहीं होगा कि the way you're going to manage time is that you're obviously not going to write these equations, क्योंकि you'll have the equations given or printed next to the question इस तरह करके. So you'll do all your working over here, but you don't have to like rewrite the whole equation. When a question can you just write the equation that you eventually find out. So all this working over here, you're not supposed to actually like write all the candidate equations, and then most of the working will be done on the where the electrode reactions are written. अच्छा, अब इसी तरह कर लेते हैं कोई anything, any random two reactants. अच्छा, इसमें ना
Can we do one with a complex ion?
कर लेते हैं. उसमें कोई इशू नहीं है. कॉम्प्लेक्स आयन एक तो वैसे पढ़ा नहीं है. पढ़ा है वैसे, पता है कि क्या होता है कॉम्प्लेक्स आयन?
A little bit last year.
अच्छा, नहीं लास्ट, हाँ ठीक है, जो उसमें थोड़ा बहुत आइडिया होगा. अच्छा, एनीवेज, तो कुछ नहीं, इट्स द सेम थिंग, इट्स एग्जैक्टली द सेम थिंग. यहाँ पे कर लेते हैं कि लेट्स से आई हैव कॉम्प्लेक्स आयन के जो रिएक्शन है, देयर वेरी फ्यू. देयर इज वन ओवर हियर. ठीक है, अब खैर मैं इसलिए कॉम्प्लेक्स आयन डिस्कस नहीं करना चाह रहा, क्योंकि सारे फिर परेशान हो गए कॉम्प्लेक्स आयन होता क्या है. ठीक है, सो राइट नाउ जस्ट थिंक it's just another molecule. ठीक है, think of it as another substance. You're going to study this in detail in transition metals. अच्छा, so ये square brackets में ना, it's always a complex sign. uh, अच्छा, now you've got a complex sign over here gaining electrons, nickel. ठीक है, so you've got this reaction. ठीक है, let's say I want to find out what will happen कि if nickel is, let's say, nickel and ammonia and water are added. ठीक है, एक मैं देख लूं कि वाटर ऐड करना सेंस भी बन रही है कि नहीं. वाटर कहाँ पे है? हाँ चलो ठीक है. अच्छा, मैं वर्किंग में इसकी वर्किंग में यहाँ पे कर रहा हूँ. अच्छा, आई गॉट अ रिएक्शन ऑफ वाटर दैट्स माइनस. अच्छा, वाटर बहुत नेगेटिव है. काम नहीं चलेगा. नेगेटिव वो लूज करेगा. थोड़ा सा कोई पॉजिटिव चीज हो. एक सेकेंड. चलो किसी किसी भी दो को कर लेते हैं. I've got this reaction and I've got let's say I've got the tin 2 plus reaction, right? तो अच्छा, अहमद है वही चीज एग्जैक्टली. इसमें कोई नई चीज नहीं है. इट्स सो who's going to gain electrons? The one that's got the higher potential. ठीक है, one of them has minus 0.51, the other one has minus 0.14. So who's going to gain electrons? It's the higher potential, right? So which is this one. तो higher gain करेगा, so that's going to go forward. और वो दूसरा जो है, that's your lower, so it's going to go backward. ठीक है, तो and you can make the overall equation, which is kind of two electrons gain, two electrons lost, that's equal. So you don't need to multiply it. You'll just add the equations up in exactly the same way. ठीक है, तो अहमद क्लियर है कि अभी फिलहाल मतलब इस चीज का क्या नाम है, VO2 प्लस क्या होता है, VO3 minus 1, that's kind of irrelevant. ठीक है, they've given you thousands of equations. Just remember the higher gains and the lower losers. ठीक है, ये क्लियर है?
Yes, sir.
तो मैं वही कह रहा हूँ कि कॉम्प्लेक्स आयन है, गैस है, एक्वस है, इट डजंट रियली मैटर. उस द रिएक्शंस आर गिवन, यू जस्ट गो एंड लुक फॉर your suitable electrode reactions and you just figure out who gains and who loses. ठीक है, so everything will be done in exactly the same way. अच्छा, अब ये कि अच्छा, बिफोर वी मूव ऑन, एक बल्कि एक क्वेश्चन और कर लेते हैं. ठीक है, अगेन समथिंग टोटली रैंडम. PbO2 है यहाँ पे. कहाँ पे रिएक्शंस? So acidified PbO2. So let's do अच्छा, लेट्स डू एसिफाइड PbO2 एंड रिएक्ट इट विद, किस साथ रिएक्ट करें? एसिन थोड़ा बोरिंग हो गया. लेट्स रिएक्ट इट विद मैग्नीशियम क्लोराइड. ठीक है, अब देखते हैं कि मतलब क्या होगा इसके बीच में. ठीक है. अच्छा, now remember one thing. अच्छा, one thing that is important is that यहाँ पे ना स्टार्ट में I told you about, कहाँ पे लिखा था reactants? अच्छा, यहाँ पे मैं थोड़ा सा reactants के बारे में. ठीक है. Remember aqueous ionic compounds should be treated as separate. Their ions should be treated as separate species. So the ions are dealt separately. Like if you have, ये भी पहले explain किया था, if you have NaCl which is obviously going to be in aqueous state, so you're going to think of it as Na plus 1 and Cl minus 1. अच्छा, लेकिन if you have an ionic compound that is not soluble, ठीक है, कॉपर हाइड्रोक्साइड है, it doesn't dissolve, it's insoluble. ठीक है, so insoluble ionic compounds are going to be treated as one thing. मतलब इसको आप उसका नहीं कंसिडर कर सकते कॉपर 2 प्लस कोई और चीज है, OH माइनस वन समथिंग एल्स, क्योंकि if something is insoluble, that means the ions are always together. That means the compound is always intact. When you have an aqueous ionic compound, तो ions सारे अलग हो जाते हैं, they dissociate. So copper hydroxide is an insoluble ionic compound and should be treated as one thing. So it's dealt as a single compound. ये बात क्लियर है?
Yes, sir.
Yes, sir.
ठीक है. तो मतलब कॉपर हाइड्रोक्साइड अगर दिया हुआ है ना कि उसका रिएक्शन, डोंट थिंक ऑफ इट एज कॉपर 2 प्लस एंड OH माइनस वन, थिंक ऑफ इट एज कॉपर हाइड्रोक्साइड वन थिंग. NaCl गिवन होगा, देन इट्स गोइंग टू बी Na plus 1 सेपरेटली, Cl minus 1 सेपरेटली. अच्छा, तो PbO2 के अंदर व्हाट इज द चार्ज ऑन Pb? इट्स प्लस 4, राइट? लेकिन PbO2 इज insoluble. Lead compounds are very insoluble. Like oxides, hydroxides, they're all insoluble. So in the case of PbO2, don't think of it as Pb4 plus. Think of it as PbO2. Because it's not going to dissolve and it's not going to form dissociated Pb4 plus ions. तो खैर ये equation हमारे सामने, I'm just going to copy this equation. So it's what? वापस चले जाते हैं. अच्छा, so this equation, it's PbO2 is one of my reactants plus 4H plus 1 plus 2 electrons. अच्छा, बन पता नहीं क्या रहा था, एक सेकेंड, क्या बन रहा था? अच्छा, ये डेटा बुकलेट 9701 डेटा बुकलेट, जस्ट गूगल इट एंड डाउनलोड इट. Pb2 plus 2H2O. अच्छा, एंड दिस इज कितना है ये? 1.47. So I found only one equation that involves PbO2. कहीं और तो नहीं है? नहीं, I guess that's the only one. अच्छा, MgCl2. Now MgCl2, I'm not going to think of it as one compound क्योंकि Mg is, I mean, it's soluble, right? So MgCl2 में Mg2 plus होगा. There's only one equation for Mg2 plus, that's minus 2.38. अच्छा, ये रिएक्शन जो है ना गलत हो गया, वो मैं एक्सप्लेन भी करता हूँ. अच्छा, and then there was MgCl2 है, तो Cl का वही है, that's Cl2 plus 2 electrons. This is 1.36 volts. ठीक है, so I had PbO2, I had 4H plus 1, I had Mg2 plus, and I had Cl minus 1. तो मैंने सारों के इलेक्ट्रोड रिएक्शंस लिख लिए, ठीक है। अच्छा, नाउ ये वो एग्जांपल है कि where a reaction is not going to happen, लेकिन we're going to apply the same rule, ठीक है। we're going to apply the same technique, which is the highest one is the one that's going to gain electrons, right? So who's the highest one? That's 1 point, अच्छा ये minus था। I said, so the highest one is 1.47, so that's the one that gains electrons. So that's my highest potential, right? Or ठीक है, that gains electrons. So acidified PbO2 gains electrons. Everything works perfectly, so that's fine. Clear है बात?
Yes, sir.
Yes.
ये clear है? Ahmed clear है? Saad, Tasneem, is this clear?
Yes, sir.
आवाज आ रही है? Hello?
Yes, sir. Clear.
अच्छा, मुझे आवाज नहीं आ रही। उमैद, अब बोला है कुछ आपने?
Yes, sir. Clear, sir.
हुमैद, अभी अभी भी बात करो ऐसे। हेलो।
Yes, sir. We can hear, sir.
Yes, sir.
अच्छा, एक सेकंड देना, मैं अपना वो ये मैंने उतारा था, मैं माइक अपना टेस्ट कर।
Hello?
Yes, sir.
Yes, sir.
अच्छा, चले, मैं वो मेरी आवाज थोड़ी सी चेंज हो जाएगी, मैंने वो उतार दिया, स्पीकर उतार दिया, ठीक है, तो होपफुली क्लियर हो, ठीक है। सॉरी, माइक उतार दिया। I couldn't hear you. अच्छा, anyway, so this is your highest potential, right? And the other one is you have to find your lowest potential, ठीक है। Now, even if you try to figure out your lowest potential, इन सारों में lowest कौन सा है? It's this one, right? But you're not going to use this because there is no Mg. I mean, you don't have Mg in your reactants. You've got Mg2 plus. So which is why I'm going to cut this out. Okay, it was the lowest, but it's not applicable to my reaction. अच्छा, फिर I'm going to find the next lowest potential, and that comes out to be E आता है ना, Cl minus 1, right? So it comes out to be 1.36, right? So this is the one that loses electrons, right? So I do have Cl minus 1. ठीक है, I've got Cl minus 1 in my reactants. तो ठीक है, काम चल गया. Actually, reaction हो गया. So I got the highest one and I got the lowest one. Is that clear?
Yes,
Yes,
sir.
sir.
और फिर उनका ना वो बना लो reaction के the electrons gained and lost are equal. तो add up कर लो, that's PbO2. That's the reactants. Add up the reactants. First equation, these are your reactants. Second, it's 2Cl minus 1. And then you've got your products. In the first one, it's Pb2 plus 2H2O, or second one में ना it's Cl2. तो अच्छा, रिएक्शन जो है वो बन गया, and you're going to calculate the E naught cell. So E naught cell is reduction potential, which is वो जो पहला वाला है, that's 1.47 minus the oxidation potential, which is 1.36. So this comes out to be kind of a small value. It's 0.11. So that comes out to be 0.11 moles, which is small, but it's still feasible. ठीक है, तो इसका मतलब there is a reaction, but it's not going to be that fast, or it's going to be very slow. ठीक है, ये clear है?
Yes, sir.
अच्छा, इसमें मैं वो ऐड कर दूं कि मुझे क्यों लगा था पहले कि why did I feel that there was no reaction going to happen? What is important is that if your E naught cell comes out to be greater than 0, that means the reaction is feasible. Sometimes what will happen is that the E naught cell will come out to be less than 0. That would indicate कि overall जो cell है ना उसका potential negative है. उसका मतलब है the cell actually needs the electrons to flow in some other direction, not in the direction you're suggesting. So that indicates that the reaction is not feasible. तो अगर ये करने के बाद if your E naught cell comes out to be less than 0, and I'll give you an example for that. ठीक है, but this is important कि you know this. Anything that's a positive E naught cell, that's feasible. Negative का मैंने एक example देना था कि let's say I want to do a reaction where I've got Na+1, Cl-1 और Al को मैं ऐड कर रहा हूँ. ठीक है, so this is an example of a negative potential. That just indicates that the reaction is not going to happen. So we already know that this reaction will probably not happen because again, if you know O levels, a more reactive metal displaces a less reactive metal. In this case, Al is not the more reactive metal, so it's not going to displace Na+1. ठीक है, so the reaction is not going to happen. Electrode से भी figure out कर लेते हैं whether a reaction will happen or not. So Na+1 का तो वही electrode है, it's one electron in equilibrium with Na. Al का 3 plus 3 electrons and it's Al, और Cl का वो है Cl2 plus 2 electrons and 2Cl minus, इसका पता है 1.36. Al का भी पता, that's minus 2.71. Na का we're gonna go and check. Na is कहाँ पे है? In next Na top पे. Na is नहीं, not Na, किसका करना था? Al. Al is minus 1.66. So this is minus 1.66. So I'm just going to mark my reactants. My reactants were Na+1. ठीक है, एक ये था. The other reactant was Cl-1, and then I had Al. ठीक है. अब इसमें ढूंढो who's got the highest potential, right? So the highest potential at the moment is the last one. Again, I'm not going to take it as the highest potential because it will be Cl2 that will be gaining electrons. So I don't have Cl2. Clear बात? ये पहला highest reject हो गया. ठीक है, is this clear?
Yes.
Yes, sir.
अच्छा, फिर बाकी दो में who's the highest? It's minus 1.66. लेकिन वो भी रिजेक्ट हो जाएगा क्योंकि if it gains electrons then it's Al3 plus that gains electrons. We don't have Al3 plus in my reactant, so I'm going to reject that as well. अच्छा, फिर पीछे कौन रह गया? Who's my highest potential? My highest potential is the first one, and that's fine. क्योंकि Na+1 is going to gain electrons, right? So Na+1, I do have Na+1. ठीक है, so I've figured out my highest potential. अच्छा, उसके बाद so I figured out my highest potential. Then I'm going to go and look for my lowest potential, the one that's going to lose electrons. So in सारा में who's the lowest at the moment? वो भी Na ही आ रहा है. ठीक है. Lowest at the moment is Na. It's going to lose electron, but I don't have Na in my reactant, right? I got Na+1, but I don't have Na. So इसलिए I'm just going to, I can ignore this one. अच्छा, Na को छोड़ के who's the lowest now? The lowest is minus 1.66, so that's fine. I do have AL you ऊपर reactants में, so that's the one that's my lowest. तो ये clear है यहाँ तक कि highest और lowest को मैंने किस तरह select किया है? Is this clear? कोई question तो नहीं है इस पे?
Clear, sir.
ये सारों clear है? Saleh, is this clear? Tasneem, Harun, clear है? अच्छा अब
Yes, sir.
चलो ठीक है. अब यहाँ पे ये कि so I did it in exactly the same way. अच्छा, but when I'm going to calculate, so I can come up with a reaction. वो पहली वाली equation को I would have to multiply by 3 ताकि electrons gain and loss are equal, right? So I can just combine the two equations. The reactants is 3Na plus 1. And the other one is Al, the reactant is Al. And the product is पहले वाले में it's 3Na. And the second one it's Al3 plus. अच्छा ये भी आ गया. अब ये कि I can go and calculate the E naught cell. So E naught cell किस तरह बताया था? It's higher minus lower or reduction minus oxidation. So if I do either one of them, I mean reduction is the first one, so that's minus 2.71. Minus oxidation is the second one, that's minus 1.66. मुझे तो वैल्यू क्या आ रही है?
Sir, negative 1.05.
So we're getting negative 1.05 moles, right? Now this negative indicates that the whole reaction is not going to happen, or it will happen in the opposite direction. क्योंकि issue ये हुआ है, the highest that you selected was actually not the highest. मतलब जो आपने highest select किया और जो आपने lowest select किया, highest है ही नहीं. I mean, your highest is actually lower than the lowest. So मतलब it's basically you messed it up. The highest, which you think is the highest, is मतलब उन सारों में it's actually the lowest. So it will not happen. It's not going to gain electrons because it is in fact, out of all the three reactions, it is actually the lowest potential. ठीक है? तो वो नेगेटिव पोटेंशियल इंडिकेट करता है कि जो आप कर रहे हो ना वो बस आप फजूल में कर रहे हो, होना कुछ भी नहीं है. ठीक है? Is this clear?
Yes, sir.
Yes, sir.
So you can use the same method, but if your E naught cell eventually it comes out to be negative, that means nothing will happen. Either that or it means के the reverse reaction, negative potential का मतलब है कि electrons जो है ना वो उल्टी direction में flow करेंगे. That indicates that the whole reaction will happen in this direction, not in the direction that you're thinking it will happen. ठीक है? और ये भी याद रख लेना कि अगर एक रिएक्शन को आप उल्टा करते हो ना, तो वो जो पोटेंशियल है ना, दैट आल्सो द साइन चेंजेस. क्योंकि द रिडक्शन माइनस ऑक्सीडेशन, इट्स गोइंग टू बिकम द ऑपोजिट. द वन दैट्स लूजिंग एंड द वन दैट्स गेनिंग वो ऑपोजिट हो जाएंगे. तो so a negative potential, but see, negative potential indicates that the reaction is not going to happen, or the other meaning of that is that the reaction will happen, but it will happen in the opposite direction, not in the direction that you are suggesting. ठीक है? तो clear है, E naught cell less than 0 not feasible. Is that clear?
Yes.
Yes, sir.
अच्छा अब ये कि बाकी काम इतना मुश्किल नहीं है. अगर आप इसको स्टेप, इसमें गलती के चांसेस बहुत हैं कि you can make a lot of mistakes when you're doing this, so you need practice. But mainly what happens is that, I mean, but what steps important. If you miss out a step, if you miss an equation, then your whole final answer would come out to be wrong. अच्छा अब इसमें ना एक, there's another one. I mean, same idea, same thing. ठीक है? Everything is exactly the same. That is super complicated. ठीक है? लेकिन everything is exactly the same. There's a thing called a chain reaction. ठीक है? Now a chain, but I'm just calling it a chain reaction. No one, I mean, I don't know if anyone calls it a chain reaction. But the idea is that sometimes what will happen is that a substance will get oxidized. ठीक है? For example, there's an SN and it's reacting with something, and it ends up losing 2 electrons. It becomes SN2 plus. But then once the first reaction is over and it becomes SN2 plus, there's going to be a follow-up reaction. That SN2 plus would then further react and it will turn into SN4 plus. Okay, so we chain reaction. There's going to be first reaction and then there's going to be a second reaction. Problem ye ke they don't have, I mean, so SN could directly turn into SN4 plus as well. Problem is in our table, because in our table, the oxidation states change in steps. Like if I look at SN, they could have given us an electrode where SN directly changes into SN4 plus. But that electrode is not here. Okay, at least because यहाँ पे तो बड़ी limited, they just gave you limited equations. So if SN were to change into SN4 plus, it's going to undergo a first reaction. It will turn into SN2 plus, and then further that SN2 plus will turn into SN4 plus. दूसरों के ना खासतौर पे अच्छा, there are very few species that have multiple oxidation state. Look at vanadium. Vanadium has a lot. Like vanadium will, अगर vanadium को +5 तक लेके जाना ना, so there'll be a number of reactions. First, vanadium will turn into vanadium 2 plus. Then that vanadium 2 plus will turn into vanadium 3 plus. Then that vanadium 3 plus will turn into ये क्या है? +2 है क्या ये? मतलब what is vanadium over here? That's +4. ठीक है. I think it's +4. Then that vanadium +4 will turn into vanadium +5. क्या होता है VO2 plus? That's -4. So must be +5. Yeah. Then that vanadium मतलब ये फिर different हो गया. अच्छा, but like idea clear है कि sometimes you'll have multiple reactions. ठीक है, I'll give you an example. और इसी का कर लेते हैं. But basic idea समझ आया ना कि इसमें इन reactions में क्या मसला होगा? Is that clear?
Yes.
अच्छा, let's start with tin. बस ये कर लेते हैं, उसके बाद फिर खत्म कर देंगे. अच्छा, let's start with tin and iodine, right? So I'm going to try and figure out what the reaction is. So there's going to be a first reaction. Tin की equation है, वो the data booklet में, that's tin 2 plus 2 electrons and in equilibrium with tin. And then there is iodine plus 2 electrons. अच्छा, दोनों का ना tin and iodine. There's only, in the entire data booklet, there's only 2 reactions. That's it. This is 0.54 volts and tin वाला क्या है? ये यहाँ पे, this one, -0.14. ठीक है, so अच्छा, काम आसान है. लोअर ने क्या करना है? लूज करना है इलेक्ट्रॉन. ठीक है, so that's fine. I've got 10. Higher is the one that's going to gain electrons, so that's easy. ठीक है, so that's going to gain electrons. ठीक है, I got my reactant, so everything is fine. So you're going to have the first reaction, and I'm going to write the reaction. So tin, the reactant, the other reactant is iodine. They're going to react, and the products are tin 2 plus and 2i minus 1. Or E naught cell भी calculate कर लो. That's reduction 0.54 minus oxidation, which is minus 0.14. ठीक है, so that's going to come out to be 0.68 more. So everything kind of looks fine. So that's my first reaction. Or let's say यहाँ पे लिखा हुआ है कि iodine is in excess. So that's our first reaction. अब मुझे बताओ कि in your container, what do you have after the first reaction? अच्छा, so after the first reaction, the products that have been formed are tin 2 plus and I minus 1. अच्छा, ये वाला reaction जो है ना, chain reaction, ये बहुत rare है. Most of the questions are going to be easy, but they do come in the paper, but like after like 3-4 years. Asha, so these are the products that are formed. Plus iodine is in excess, so there is still a small amount of iodine still left because it was added in excess. ये clear है कि पहला reaction हुआ है and these are your this is what's roaming around in the solution. Is that clear?
Yes.
Yes, sir.
तब आ जाओ अगला reaction. अब बताओ कि reactants क्या हैं आपके container में. You got 10 2 plus, you got I minus 1, and you got iodine which is in excess. ठीक है. So you now need to figure out whether there's going to be a second reaction. So दोबारा लिखने शुरू कर दो. डेटा बुकलेट में जो कुछ है ना 10 2 plus plus 2 electrons in equilibrium with 10. ठीक है. So 10 2 plus, that's minus 0.14. There's another equation for 10 2 plus where it's in equilibrium with 10 4 plus 2 electrons. उसमें वो बन रहा है 10 2 plus. ये मेरे ख्याल से this was 0.15 volts. Iodine वाली there's only one which will cover both. 2 equilibrium 2I minus 1, that's 0. So I'm going to highlight my reactants. My reactants are 10 2 plus, 10 2 plus, and दोनों types का iodine है solution में. अच्छा, so the higher one is going to gain electrons. So ठीक है, that's your highest, and that's fine. Iodine is the one. I do have iodine over here, so that's going to gain electrons. Who's going to lose electrons? The lowest one. So the first one is the lowest one, but I don't have 10 anymore. Okay? I don't have 10. वो पहले reaction में 10 has turned into 10 2 plus, so there's no 10 left. Okay? So I'm just going to get rid of this. 10 will not be able to lose electrons because there is no 10. तो अब lowest कौन सा है? Lowest ये वाला है. ठीक है, that's my lowest. ये clear है?
Yes, sir.
So 10 2 plus electrons reacts with iodine, and the product is 10 4 plus and 2I minus 1. Okay? And you can calculate the E naught cell, which is higher minus lower or reduction minus oxidation, which is 0.54 minus 0.15. So you're getting a positive 0.39 out there, my cousin. Achha, so now you had the first reaction, and now you had the second reaction. So in the first one, 10 turned into 10 2 plus. So your container had 10 2 plus. It still had excess iodine. It had I minus 1. Then you tried and figure out whether there's going to be a further reaction. You found out that there is going to be a further reaction, and that 10 2 plus will further turn into 10 4 plus. Is that clear?
Yes, sir.
Yes, sir.
और बस फिर यहीं पे खत्म हो जाएगा. 10 4 plus के बाद further oxidation, there is no equation for that. So 10, so which is why it was happening in two steps, because there was a missing electrode reaction which was not given. अगर वो दे देते ना तो फिर काम आसान था, हम उसी को यूज कर लेते. But right now we don't have that reaction, so we figured out what's going to happen. And so there are two reactions, and what you can do is you can just add up the two reactions. ठीक है, दोनों को पकड़ो, तो दोनों को add कर दो, you'll get the overall reaction. So if I start adding them up, so I'll get this. I'll get 10 plus 2I2, and the product is going to be 10 4 plus and 4I minus 1. ठीक है, ये cut हो जाएगा. 10 2 plus is on the right side, and you got 10 2 plus on the left side. And if you add up the reactants, you add up the products. So anything that's appearing on the right side and also appearing on the left side, that math की तरह gets cancelled out. That means it's really not doing anything. ठीक है, तो बीच में ना 10 2 plus, because it's appearing on both sides, gets cancelled out, and you find your overall reaction. ठीक है, तो जो chain reactions है ना, you have to figure out whether there's going to be another reaction after the first reaction. उसके अंदर there are two issues. One is you have to track, like पहला reaction हो गया तो पीछे क्या पड़ा हुआ है. You have to track what's left. And then you have to, based on that, you have to figure out whether there's going to be another reaction or not. And और इसकी ना chain reactions की, the only time chain reactions will bother you is any species that has multiple oxidation states. Like for lead, you have to be careful that lead might turn into lead 2 plus, and then lead 2 plus might further turn into lead 4 plus. So, jinki multiple oxidation states, hai na, for vanadium, you have to be worried that you might have a chain reaction. A lot of substances will not have chain reactions. Like Na will turn into Na plus 1, that's it. कहानी वहां पे खत्म हो जाएगी. There is no further oxidation state. That's it. ठीक है. Nickel will turn into nickel 2 plus. After that, nothing is happening to nickel. तो substances जिनकी एक ही oxidation state होती है ना, तो you don't need to worry about their chain reactions. Mn का issue है. Mn, look at Mn. It turns into 2 plus, then turns into 3 plus, then turns into 4 plus, then turns into यहाँ पे क्या है? I think 7 plus. So Mn has a lot of multiple oxidation states. ठीक है. तो इस पे ये कर लेते हैं. Remember this. अच्छा फिर से वो simplify कर लूँ. This is rare. ठीक है. You gotta get a question like after 4-5 years, but it's a rare question. Most of the questions are going to be relatively very simple. ठीक है कि I mean they're going to be relatively very very simple. लेकिन ये फिर कल हम थोड़ा सा टाइम वैसे जाया करेंगे इसके ऊपर कि we'll try and do a bit more questions. Although this one is not that important, we're going to try and do some slightly more difficult questions related to this. ठीक है. चलो ठीक है. Let's continue tomorrow then. ठीक है. और कोई
Okay,
question?
thank you, sir.
Hafiz.
Question नहीं है ना कोई?
No, sir.
No question.
Okay, take care. Hafiz.
After, sir.